Saxon's Trig, lesson 79, is about de Moivre's theorem and roots of complex numbers. Now, de Moivre, mathematician in the past, and what he discovered was that if I take r cis theta and I take it to a certain exponent, we'll call it n, we know that if it were like 2 cubed, that would mean 2 times 2 times 2. So you're writing this cis statement however many times this is and simplifying the answer. So what de Moivre discovered was that when he did the long work of writing this out and doing all of the manipulations, that when he took the r and he gave it the nth power, like the 2 cubed, that was a simple solution. And as we learned before, when we are multiplying things with cis, we're actually adding. So when he was adding them up, basically what he needed to do was take cis with the n, whatever the exponent was, and multiply that with his theta, and that was the simplified version. That's what de Moivre's theorem does. So now let's do some actual examples with it. Example 1 says find 2 cis 30 degrees to the 5th power. So you're going to break that to 2 to the 5th and cis 5 times 30. That's basically that formula. So 2 to the 5th, 2 times, you can do it on your calculator or you can do it manually. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 again is 32. Cis of 5, that's 150 degrees. And with very little work, I have found that answer much better than trying to write this out 5 times, graph it, manipulate it, and so forth. Example 2, use de Moivre's theorem to find 1 plus, lost the problem, I to the 13th power. Express the answer in rectangular form. Now, is this 1 plus I to the 13th in the nice cis form that I need to use de Moivre's theorem? It is not. So I need to stop and put it in cis, which means I'm just going to graph it in the first quadrant. 1 and the implied 1, so 1 over 1 up, Pythagorean theorem to get the hypotenuse, that makes that root 2. So in cis format, root 2 is the hypotenuse with the cis, and then I need to clarify what degree this was. Well, with 1, 1, and root 2, that's memorized, 45 degrees. So now I've converted it, and they want this to the 13th power. So we do root 2 to the 13th power, cis 13 multiplying with the 45 degrees. So every time I have a set of 2, I have multiple ways to think my way through this. I can do that on the calculator, or I can say, how many sets of 2s do I have in 13? Well, if I have it, that gives me 6 and an extra. So 6 sets of 2, that's basically 2 to the 6th power with the extra root 2 stuck at the end. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 again should be 64. 64, and then I have my cis, oh, forgot my root 2, cis of, and 13 times 45 is 585. Okay. That 585 is more than 360, so I know this is not in its simplified form. So if I subtract 360 off, I get 225. That is low enough to be in its simplified form. So I have basically 64 with my root 2 that I had to cram in there, cis 225 degrees. Now that's a beautiful answer using de Moivre's theorem, but the problem said put my answer in rectangular form. Typically, I will say you can leave the answer here, but just because this example wants it in rectangular, let's take a look at what that looks like. So we need to graph 225 degrees. 0, 90, 180, 270. It's before 270, so it's in quadrant 3. How much past the 180 are we going? 45 degrees. And you'll find that it should match up with what it was before. It's just a matter of figuring out what quadrant it's in. So this is -1, this is -1, this is root 2. So that makes the x value negative and the y value negative. My hypotenuse, I labeled it as I should with a 45. But in this, what was my hypotenuse actually given as? 64 root 2. So what am I doing to this root 2 to turn it into 64 root 2? I'm multiplying it by 64. So that's what I need to do with each of these. So they're going to turn into the -64. So I now know I have -64 and -64 for both of the directions. Here's my x1, here's my y. Remember when you have cis, that it's not I and j anymore, it's the I written at the end only. So this one gets the I, and now it's in rectangular format. Okay, part B, roots of complex numbers. Complex means I'm dealing with the I, imaginary numbers, the messier kind of answers. And then roots means I'm trying to square root, cube root, fourth root, something or other, root these numbers. Now they go through a lot of explanation on page 481. I'm going to jump over to example 3, but I'm going to basically say whatever your root is, if it's 3, you're supposed to have 3 answers. If it's 4, you're supposed to have 4 answers. And that will help you as we do this problem. That's kind of what they were trying to explain on page 481. So the problem says find the 4 fourth roots. So I know that we're dealing with a fourth root, and that means 4 separate answers. And it gives me to begin with 16 cis 60 degrees. Find the 4 fourth roots of that. Check the answer by multiplying. We are not going to check the answer by multiplying. So we are trying to do the 4th root of this, basically. So it's kind of like undoing de Moivre's theorem. Instead of taking, oh, forgot to write the 4th. Instead of taking this to an exponent, we're doing it to a root. So we're going to separate this out to the 4th root of 16, cis, and instead of multiplying, we're going to divide. 60 divided by the 4. So which number 4 times gives me 16? That's 2, cis, and then 60 divided by 4 is 15. That is my first of the 4 answers I know I'm supposed to get. So all of them will have the same hypotenuse every time. So I know I can write that out. Then I need to find a pattern that changes the degree. So I'm basically wrapping 3 more times. I'm total wrapping 4 times. So you're going to take 360 for a full circle and divide it by whatever the root was, and that tells you how much you're going to add in the degrees each time. So 360 divided by 4 means I'm adding 90 each time. So 90 plus 15, oh, they're going through a much longer, is 105. 90 plus that is 195, and finally 285. And there are my 4 answers. Okay, now that we've established that, let's do example 4. Find 5 fifth roots of I. Oh, I is all they gave me. Yikes. What is implied here then? Because it should be with 2 parts, an x part and a y part. If the I is the last thing, that's the y part, and it definitely implies a 1i. So nothing here plus 1i. That looks a little better for rectangular format. Okay, great. So before I do the root, I need it in cis format, so we're going to graph. Now I know what I'm graphing, 0 plus 1i. Not moving over. I am moving up by 1, so my fake triangle is going to be here. I'm moving up by 1. I am not moving over at all. Hypotenuse will match at 1. Great. I have 1 cis, and what degree is not moving over but moving up? I'm on this line. That's 90 degrees. Great, now I'm in cis format. It wants the fifth root of this. So the fifth root of 1 cis 90 divided by 5. 1, it doesn't matter what the root is, it's going to be 1 cis, and 90 divided by 5 is 18 degrees. That's my first answer. How many answers will I have? Fifth root, 5 of them. All of this will remain the same for all 5. Now I figure out what I need to add to the degree each time. 360 divided by the 5. That's not going to be pretty. That's 72 degrees. All right, so 72 plus 18 should be 90, right? Yes. Then 90 plus 72, 162. Then 72 more than that is 234. 72 plus that is 306 degrees. Here are my 5 answers. I noticed that they are doing, oh, that's their check, which I'm ignoring. Okay, example 5. Find 2 square roots of 1, and 1 is all they give me. All right, well, square root seems like it should be easier. Obviously, it means only 2 answers, so that's much nicer. But this, like this, is not in the right format. It's implying a 1 plus nothing I, so that I can graph it and turn it into cis. So I am moving over 1, but not up. Not up, moving over. Hypotenuse will match, so I know I have 1 cis. Moving over here makes this 0 degrees. And I want to take the square root of that. Square root of 1 is 1. And I know I'll have 2 answers, 1 cis, 1 cis. And then 0 divided by 2 is still 0 for my start. 360 divided by the root of 2 tells me I'm adding 180 each time. 180 plus 0 is 180. Oh, and then they said they checked their answers. They're good. Here are my 2 answers. Okay, example 6. They do quite a few of this one. Find 3 third roots of negative 1. Again, that implies 0i, graphed, going backwards but not up, fake triangle quadrant 2, going backwards negative 1, not up, will match with the 1. So I have 1 cis, 180 degrees, and it wants the cubed root of that. Cubed root of 1 is 1. I will have 3 answers. 180 divided by the 3 is 60. To establish the pattern for the remainder, 360 divided by 3 is 120 degrees to add. So that's 180 and another 120. That's 300, I believe. Yes, 60, 180, 300. Now, it just said find the roots of, so I would keep my answers here. I see that they went ahead and changed it to rectangular form. There's no reason that I have to do that, and since there's no reason to do extra work, I won't. If you needed to put them in rectangular, you would have to graph each and every one of them and then list their x and y values with the I at the tail end. Final example 7, find the 4 fourth roots of 42 cis 40 degrees. And it wanted the 4th roots. So the 4th root of that is basically what we're trying to do. So you're gonna have to, and because this is not an even number, you need to do it on the calculator. So however your calculator wants you to plug in 42 first, then the 4th root of, or it might want 4 first and then the root and give it the base of 42. But however it works, it should be spitting out 2.55 cis. And then how many of those will I have? 4. 2.556. Okay, there's my 4. And then I take my 40 and I divide it by my 4th root, so I know my first one is 10 degrees. Then I establish the pattern by doing 360 divided by that same 4th root, so that's 90 degrees, adding each time. 90 plus 10 is 100, 190, and then 288, yeah, I believe that's right. Yes, 280. Okay, there are my 4 4th roots.